everyone. Today we will understand confusion matrix. First of all, in confusion matrix, we basically deal with actual versus predicted. First of all, conduct a matrix first, then we will understand confusion matrix. So this is a 2 by 2 matrix, and here we will predicted, and here will be our actual. Okay, first understand. Suppose there is a machine who can predict things. Say for example, you liked my video or you rated my video as 4. In reality, it's 4, but this machine predicts it 5. So actual and the prediction is not correct. For another video of mine, you predict actual was 3 and the machine predicts 3. So these two are equal. So basically that will happen inside this confusion matrix, where here we all perform actual versus predicted. You can consider predicted as a machine that will predict things, actual as a reality, and then we will have our cases. In confusion matrix, we basically deals with binary cases. Say yes, no, yes, no, same as yes, no. So yes, yes, so that will be our yes, yes, and that will be our yes, no, that will be our no, yes, that will be our no, no. Okay, and now there is important facts will come out here. First of all, let's understand what is it, this predicted thing. This predicted thing is in this column is positive, and what is this positive? Is it true or false? Yes, it is true. Then it will be named as true positive. Why it is true positive? See here, actual and the prediction are equal. That's why it's true positive, because the machine correctly predict the positive. Next one, if you see these two are not equal, so this is what is the predicted thing the machine predicts. The negative predicts negative. And what is this negative predicted as? Yes, it's false, because they are not equal, so it's false. False negative that the machine predict. The second observation will be our prediction, and the first, then it will be named as is it correctly predicted or not correctly predicted. And if you see that these two are equal, so it's correct. What is it? It is a negative. Is the negative correctly predicted? Yes, then it will be true negative. This one, these two are not equal. This is a positive. Is this positive correctly predicted? No, false positive. If you notice here, we correctly predict two things basically here, and these two things. So these are good things, right? But these two are not predicted as correctly. So these are errors. These are errors. These are error. These two are not such a common error. These are great. These are very famous error. Can you guess one? Yes, if you see this is a false positive, it's nothing but type 1 error. And if you see this error, false negative, it is nothing but type 2 error. Now there's a question. What is type 1 and type 2 error? I will cover it later. First, and the next observation, if you see that there's a lot of ways to represent these things, and they are very important to be understand. You see, we correctly predict the negative things, right? So this will be known as denoted, first of all, 1 minus beta. And 1 minus beta is, what is it? It is nothing but power of the test. Power of the test. Why I write 1 minus beta? Because this type 2 error denoted as beta. So combining this observation, 1 minus beta will be this part. Okay? And now this part. Here, you have to understand what is alpha. This one is called the alpha. Then this one will be denoted at 1 minus alpha. And do you know what is this 1 minus alpha? It's, yes, confidence level. Confidence level. So we dealing with the parts of our symbols, the famous symbols. Let me clear you a few things. What is a type 1 error and what is a type 2 error? Because they are very important. There's two ways can be dealt with. One is hypothesis way, another one is actual versus prediction. See, in both cases, actual and the prediction are not equal. So they are the errors. For defining them, so first of all, consider an example. Say an example of hypothesis testing, null hypothesis and alternative hypothesis. Consider a courtroom trial. In this courtroom trial, there is a judge sitting up there, and when someone has been accused of some cases, initially the judge decided or guess him as an innocent person. Then the prosecutor should provide enough evidence against this innocent guess, and it will be our guilty. Now, if we reject this null hypothesis, actually, this null hypothesis, when it is true, that will be our type 1 error. That means an innocent person will be proven guilty. What is the actual and the predicted case in this case? Say actually he was innocent. But the prediction that he was guilty. That is the fact. Again, for this type 2 error, same condition, same hypothesis. If we fail to reject the null hypothesis this time, fail to reject null, when it's actually false, then it will be known as type 2 error. What will be here the actual and the prediction case? Say in type 2 error, actual will be guilty. Prediction will be innocent. Now, as a guesswork, what type of error is more dangerous to you? Many of them guess this one because an innocent person was proven guilty. It's a massive crime. Yes, but from that, you not always conclude the seriousness of type 1 error and type 2 error. It's basically all dependent in the different scenarios. In a courtroom trial, yes, you can say that type 1 error looks uh, uh, it's a pretty it's a little bit more dangerous than type 2 error. Okay, we finished our type 1 error and type 2 error. Now we will move on to accuracy. See, this whole matrix says these two things are correct, and we want to know that overall how much the performance of our machine that will be give you by accuracy. Because of why? Because accuracy deals with true positive plus true negative. At the denominator it will be all added: true positive, true negative, um, false positive, false negative. So this is actually our accuracy will be. Okay, now our precision. What will be our precision? In this chart, this flow, this average, basically among all predicted positive, how many were correct? That will be our precision. So how we will define it? True positive. True positive is our correct, and the whole is true positive plus false positive. So among all predicted positive, this is the predicted positive. Okay, among all predicted positive, how much? This much. This much is our correctly positive. So this is prediction, precision. Okay, we finished up our precision, and then we will go for recall, one of the major thing. Okay, it's finished precision. Now we will recall. Okay, if you see here, this is true positive, right? This is true positive, and this is our actual, right? This is our actual. Among all actual positive, how many were you caught positive? Among basically precision deals with prediction. Recall, consider an opposite thing. Among all actual, how many were positive? Okay, TP plus Fn. So this is actually recall. Again, remind you is a single thing. So when you ever find out this recall will be this direction. This one, recall deals with actual, precision deals with predicted. And now another important part, we have to understand this two is balanced or not. For that, there is another method, F1 score. This is basically the harmonic mean of uh, uh, precision and recall. For two variable, a harmonic mean looks like this one: precision multiplied recall divided by precision plus recall. uh, as you can see that this is nothing but harmonic mean. And do you know what harmonic mean does? Yes, harmonic mean gives a weight for the lower value. Suppose I have two observation. Uh, you can say that I have a observation 1 and I have observation 0.1. Then if you calculate arithmetic mean, which is basically the average of these two numbers, you will find uh, 0.55, right? This gives you very good score. But is it a good score? This one is your precision, this one is your recall. After observing arithmetic mean, you can find out there is something. This arithmetic mean was not correctly interpreted the inner healings of the data. So there where we calculate an harmonic mean. If you calculate harmonic mean, you will find 0.18. This tells you yes, this machine does not correctly predict a thing. At a glance, you can say that. And this harmonic mean is nothing but your F1 score. When it is F1 score, you will say that yes, the machine was not good. And why 0.18? See, this 0.18 is very close to this recall value 0.1, because whenever you calculate this harmonic mean, it will give extra weights to the lower value. And what should very needed in this particular case, because of why? Because we need to balance precision and accuracy. We need both of them at some range of say 0.5 or 0.6. These values of F1 score indicates the machine is correctly predicted things. Okay, so we finished all of this. So now there is an important and very interesting facts that we have to look in dealing with these things. One is sensitivity and one is our uh, specificity. Okay, first one, sensitivity. Where is it? As you can see that our this one was our recall, right? This one, and this one is also our this recall is nothing but our sensitivity. Sensitivity. So how much we correctly predict things from the actual is our sensitivity, and another one is our specificity. This one is your specificity, and how it is defined as, it's basically considered as how much were negative, true negative from the all negatives. So false, positive, and true negative. So this is actually our specificity. So how much we correctly from the negatives, how much we correctly find as our negative, that is our specificity, and that is also known as part of the test. Yes, and basically specificity indicates the right thing from all negatives, how much were correctly predicted negatives, how much were negatives. And if you find out sensitivity is opposite of this specificity, from all positive, how much were positive, from all um, positives, how much were correctly predicted positive. So that is it, all from this class of confusion matrix. Thank you very much.